Good morning, ladies and gentlemen. Welcome back from spring break. I know circumstances are not the best right now, but hopefully you were able to make the best of your time. Today we're going to go through a new unit called Electric Forces and Fields, and we're going to go through section 1 today, which focuses on the electric charge. So we're going to learn what an electric charge is and how they interact with each other. Okay, so it starts us off with a prompt with the balloon and hair. I'm sure you guys have all seen that little trick. Okay, if you rub a balloon in your hair, the balloon is then going to be attracted to your hair. Why? What is happening? If you do that with two balloons, you'll also see the balloons then want to push away from each other. Why? Why does that happen? And then a third scenario they bring up is if you then bring that same balloon that you rub in your hair next to a wall, it'll stick to the wall. Why does that happen? Okay, so I have a little virtual demo here to show you. Okay, so the sweater, let's pretend the sweater is your hair. Okay, so if you look, you have a little red circle with a plus sign in it and a blue circle with a minus sign in it. Okay, the blue circle is the electrons. Okay, the electrons have a negative charge. The red circle are protons. Protons have a positive charge. And here we have our balloon. So what happens when you rub the balloon in your hair? What happens is the electrons in your hair are attracted to the balloon. So then they transfer to the balloon, and now the balloon has more electrons than it does protons. Because we have more electrons than protons, the balloon now becomes negatively charged, okay? And just like magnets, opposites attract. So positive charges and negative charges are attracted to each other. So when I let go of the balloon, notice the balloon wants to get pulled towards the hair, okay, or the sweater in this case, okay? The reason that is because the balloon is negatively charged and the hair is now positively charged, and opposites attract. That's what's going on. If I introduce a second balloon, now both balloons are negative. And look what happens when I bring the two balloons close to each other. They push away from each other. Why? Just again with magnets, if you put opposite or not opposite, if you put the same ends of magnets together, they push away from each other. So opposites attract, but if they're the same, they repel. Okay, so if you have two negative charges, the negatives repel one another. And that's also why it sticks to the wall. Notice what happens when I bring one of the balloons to the wall. Pay attention to the blue circles on the wall. As I bring the balloon closer to it, it pushes the blue spheres, the electrons, away. Why? Because the balloon is negatively charged, and negative will push away other negatives. So as we bring the balloon closer, it pushes away the electrons, and that leaves the protons. Okay, that leaves the positive charge. So now the wall temporarily becomes positive. And because it's temporarily now positive, opposites attract, and the balloon will now stick. Okay, so that is why all three of these scenarios happen. Okay, so like I said, there are two charges. You have a positive charge and you have a negative charge. Okay, positive charge, negative charge. Like charges repel. So if you have positive and positive, it's going to push away. If you have negative and negative, it's going to push away. If you have a positive and a negative, they're going to stick. Okay, they're going to want to go towards each other. Okay, so what's happening is you have a transfer of electrons. That is why you get that stick. Okay, all atoms have protons and electrons. The protons are the positive, the electrons are the negative. When they're equal, you have a neutral atom. Neutral means no charge. So if we go back to the system, if I reset it, notice how every proton is paired with an electron. If the protons equal the electrons, you have no charge. So right now, the sweater is not charged. The balloon is not charged. The wall is not charged. And when things aren't charged, nothing sticks. Notice how it doesn't stick to the wall. Nothing's pushing. Everything is neutral. So neutral, no charge. But electrons are easily transferred. So pay attention to that. It is the electrons that are being transferred, not the protons. Protons cannot be transferred. Electrons are the only things that can move. Electrons are the things that are free to move. Okay? the electrons get transferred. Remember that. The slides has a little prompt for you that explains this milk and oil drop experiment. I'm not going to go through it, but there is a video that I will post. The video is only 2 minutes long. I want you to watch it, and it'll explain this experiment. This is an important experiment. What the experiment did was it told us what the exact charge of electrons are. And by inference, electrons and protons, they cancel each other out, which means that if we know what the charge of an electron is, we technically know what the charge of a proton is, and that's exactly what happened. So this experiment discovered that electrons have a charge of negative 1.6 times 10 to the negative 19. Okay? C, this C symbol, this is a new unit that we're going to be working with. It's the unit of charge, and the unit of charge is called a coulomb. Okay, so that is pronounced coulomb. That is the unit of charge, and that's the new unit that we're going to be working with. Okay, and if you pay close attention to the mass, protons are a lot larger and heavier than electrons in comparison. They're both tiny, but the proton, if you think about the scale, is a lot larger and heavier than an electron. But even though it's a lot larger and heavier, it has the same charge. Okay, so the mass of them does not affect their charge. Okay, so just know that. Protons and electrons have the exact same charge, just opposites. Okay, here's basically a little summary. I'm not going to go through this, but I will want to talk about this. This is another important thing. Conductors and insulators. I'm sure you guys have heard the terms before, but what is a conductor? A conductor is something that allows energy to be transferred through it very easily. And I say energy because it isn't always just electricity. Okay, heat is also something that can be conducted. The common good conductors are metals. Okay, that's why we use metal pots in the kitchen. Pots allow heat from the gas stoves to be transferred easily to the food. Okay, metals are good conductors. That's why we use metal pots and pans. Okay, they allow heat to flow through them very easily, heat and electricity. Okay, then you have insulators. Insulators do the exact opposite. Insulators prevent the transfer of energy. Okay, and when would you want that? You want that inside your house. Okay, inside your house is insulation. The insulation is used to separate the inside environment of your house from the outdoors. Okay, in the winter, for example, in the winter it's cold. You turn the heat on, and you want to keep the heat inside the house, right? Otherwise, you're wasting money. The insulation prevents the heat from escaping your house and going outside. In the summer, it's hot, and you want it to be cooler. So you turn on the AC, okay? And you want to keep that cold inside the house, right? So then the insulation prevents the heat from outside from coming in, okay? So insulators set up barriers, and conductors allow things to flow. Okay, that's the difference between them. Common conductors include silver, copper, aluminum, and other metals. Okay, most of our wires and electrical components are made out of copper. Okay, and then some common insulators are plastic, rubber, and glass. Okay, so again, insulators prevent flow, conductors allow flow. Okay, that's the difference between them. And how do things get charged in the first place? You have charging by contact. Charging by contact is when you rub two materials together. And that's what's happening with the balloon and the hair, okay? So if I rub the balloon in the sweater, okay, this is charging by contact. The balloon is physically touching the sweater, and then the electrons get transferred. That is charging by contact, okay? They have to touch, okay? Then you have charging by induction. What is charging by induction? Charging by induction is when you bring something that is already charged to something that is not. So right now the balloon is negatively charged. And when I bring the balloon close to the wall, it pushes the electrons to the opposite side. So now the wall is temporarily positively charged. If I move the balloon away, it goes back to normal. And so it's not a permanent charge, but when I bring it, it pushes it away, and it temporarily, that spot becomes positively charged. We call that charging by induction. Induction, you don't need to be touching, okay? Look, I'm not touching the wall yet, and it's already pushing the electrons away. And then if I let go of the balloon, it gets attracted to it, and it pulls it all the way in. Okay, so this is charging by contact, and this is charging by induction. Okay, in this case, you have a negative pole, and then the pole pushes away the electrons. Okay, if we make a circuit out of this, so let's say this sphere was connected to a wire, what would happen then is the electrons would want to flow out. Okay, they don't like being next to each other, so if they can escape, they'll escape. Okay, and that's exactly what happens when you allow things to get grounded. Okay, so if you connect it to a circuit through a conductor, the electrons will then start to flow. So then you get a permanent charge because the electrons are now leaving. Okay, so that's what the bottom image is showing you. This right here, this is a circuit. Okay, this is a circuit. The sphere is now connected, and the electrons are now able to transfer. The one up top doesn't have a wire going through it, so that's why it's temporary. Here, same thing. The wall. What have I got? The wall isn't connected to any system. That's why when I remove the balloon, things go back to normal. But if you had a system where it was connected to the wire, you would then get flow. Okay, so that's another way to get flow of electricity. Okay. So again, charge by contact and charge by induction. When you remove the rod, things go back to normal. So the conductor connecting the sphere is removed. What type of charge does the sphere now possess? Still negative. But why the negative rod is removed? Why do the charges move into position shown? Things are trying to go back to normal. Okay, so this is okay. We understand. This is what I was explaining. Yep, cool. Surface charges. Okay, this is why does a charged balloon stick to the wall? Explain that again. Charged by induction. That's why it sticks. A positive surface charge is induced on the wall by the negatively charged balloon. Okay, you bring the balloon close to the wall, and it pushes away the other charges. Okay, that's exactly what this is explaining. This is just doing it in word form. Let's see here. Positive charge does electrons shift within atom due to the attraction and repulsion. Okay, that's exactly what's happening. So this is just explaining exactly what the diagram went through. And then we have the summary. And now hopefully you understand where it is that came from. Okay. Yes. Cool. We're good. So for today, I just have a study guide for you to do. Okay. Today I just have the study guide for you to do. And afterwards, there are a few videos. So there should be 2 videos that are going to be up. You have the milk and oil drop video. That's what I want you to watch. It is just 2 minutes. And there's another video on there. It's like 10 minutes long. That one is not, I'm not asking you to watch it, but it's there in case you want to see it. That better explains insulators and conductors, and it goes to the electric grid and kind of helps explain how it functions as well. Okay. So that's it for today. It's just the study guide and a few videos. That's all that I'm asking you to do today. My first day back. I'm not trying to overload you with stuff. Okay. Again, if you have any questions, please feel free to contact me. And enjoy the rest of your day. Okay. Take care, guys. Hope you guys are all doing okay. I know crazy right now, but gotta do the best with what you got. Okay. Take care.